Hi everyone and welcome back to another video of EDU PICO series. In this part, we will learn to build a climate control greenhouse. In this project, you will learn how to construct a control system that regulates the humidity and temperature of a closed greenhouse environment. This is how it works. Shine a light on the APDS light sensor to simulate surrounding brightness in the greenhouse. If the surroundings are bright, the RGB LEDs remain off, whereas if the surroundings are dark, the RGB LEDs will light up in violet. Test the AHT20 temperature humidity sensor by placing your finger on the sensor module. The temperature should rise gradually. If the surroundings are hot, the servo will activate to 60 degrees, opening the rooftop, and the DC motor fan will activate to ventilate the area to cool down the environment. Let's start writing the code for this activity. Line 1 to 6. These lines import the necessary libraries and modules for working with various hardware components, which include the OLED display, temperature and humidity sensor, color sensor, servo motor, DC motor, and RGB LEDs. Line 8 initializes I2C communication with GP5 for SCL and GP4 for SDA. Line 9 to 13 configure the OLED, temperature, humidity, and color sensor using the same I2C bus and pins. Line 10 inverts the OLED display, changing the background to white and the text color to black. When using I2C, each device has a unique address on the bus, allowing multiple devices to communicate with the Raspberry Pi PICO-W. Line 15 to 20 initializes RGB LEDs, DC motor, and servo motor. Line 24 to 30, light on fills the RGB LEDs with violet color, and light off to turn off the RGB LEDs while updating the OLED display with the corresponding status messages. Line 32 to 38, servo on function rotates the servo to 20 degrees, ideally to open the rooftop of the greenhouse, whereas servo off will rotate the servo back to its original state at 90 degrees, closing the greenhouse rooftop. Line 40 to 42, the temperature control function monitors the temperature from the AHT20 sensor while displaying the data on the OLED screen. Line 43 to 50, activate the DC motor fan and servo motor when the temperature is above the temperature threshold set. The temperature threshold value is set at line 66. Line 53 to 54, this loop waits until color data is ready to be read from the APDS sensor. It checks the color data ready property of the sensor. The loop pauses for 0.005 seconds in each iteration to avoid unnecessary CPU load while waiting. Line 55 to 56, read the values RGB and C color data and calculate the luminance and lux. Line 57 to 60, calls light on function when the calculated lux value is below a preset threshold, and light off function if the lux value is above the threshold. Line 61, this line updates the OLED display with the calculated light lux value. Format light lux allows .f to be replaced with the actual value of light lux. Line 64 to 69, continuously calls the temperature control function while passing a temperature threshold of 27 degrees Celsius. The code then calls the light control function, passing a light threshold of 100 lux. These functions update the OLED display with the latest data every 2 seconds and control the fan and servo motor depending on the latest temperature and lux data measured. Line 71 to 75, the finally block ensures that cleanup operations are performed, regardless of whether an exception occurred or not, during the main program execution. In this case, it clears the OLED display, print a message, and deinitializes the I2C bus. These operations are essential for maintaining the integrity of the hardware and ensuring a clean exit of the program. Well done completing the project of Chapter 8, but we are not done with this chapter yet. In the next 2 videos, we will dive into the Internet of Things and learn basic data logging. Thanks for watching, and I will see you in the next video.